Hey guys, today we're going to do number theories and integers, and we have a few problems to work, and I'll help you guys work through them. So let's get to our first problem. Okay, so we're going to do, and it didn't scan very well. I'll try to help you guys do it. So we're going to use the divisibility test to decide whether the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 are divisors of the numbers in the table given. Now I have wrote for us divisors and their test. So if it's 2, it's going to be an odd number where it ends in 0, 2, 4, 6, 8. 3, the sum of the digits must divide by 3. Some of these are pretty easy, so we're just going to go ahead and get to work on them. But there's the divisibility tables if y'all need them. Okay, so my table is sideways. It's the only way I can get it to work. So we'll just start with 684. Is 684 divisible by 2? And yes, it is, because the last number is an even digit, which is 4. Is 684, is 3 a divisor of 684? In order to figure that out, you add up all 3 digits, 6, 8, and 4, which gives you 18, and then you divide that by 3, and it's divisible by 3, so 3 is a divisor of it. Let's do a harder one. 9 is similar to what we just did with 3. Okay, so with 11, that one's a little tricky. So what you do is every alternating number, so we'll add the digits. So 6, 8, and 4 are our digits. So it'd be plus 6 minus 8 plus 4, which gives us which would be a negative 2 plus 4, which is equal to 2. So 2 is not divisible by 11, so that's a no. Let's look at our other numbers to see if any of them are. Let's go with 51,051. So plus 5 minus 1 plus 0 minus 5 plus 1, which gives us 4 minus 4, which is 0, and 0 is divisible by 11, so that's a yes. Now you just use the keys that I gave you, the divisibility chart that I gave you with the rules, and you can solve all of these pretty quickly. So let's move on to the next problem. Now we're going to cast out 9s to check each of the following answers. In order to do that, what you have to do is you replace every number in the calculation by its remainder when divided by 9. So for problem A, our first number that we're going to do this with is 69,844. When it is divided by 9, it gives you a remainder of 4. You do this with each one. So 7,490 divided by 9 is a remainder of 2. 416 divided by 9 is a remainder of 2 again. So since the problem is an addition problem, with the remainders you're going to add them too. So 4 plus 2 plus 2 gives you 8. And once you divide 9 into 8, it's just a remainder of 8. Now the answer they gave us is 112,790. When you divide that by 9, it's a remainder of 2. And as you notice, on our remainders, 2 and 8 are not the same, so they do not agree. So over here to the right, I've worked out the correct calculation. So 69,844 plus 7,490 and plus 416 is actually 77,750. We'll do one more. It's not an addition one. Okay, so here we go. Let's do the subtraction. So we have 78,362. When we divide it by 9, it gives us a remainder of 8. 3,674 gives us a remainder of 2. And before, how we added, since this problem is a subtraction problem, we're going to subtract the remainders. 8 minus 2 is 6. So 74,678 divided by 5, or divided by 9, gives you 5. When you divide 6 and 9, it'll give you a remainder of 6. 5 and 6, they do not agree, so the answer they give you is not correct. So over here we do the correct subtraction. 78,362 minus 3,674 actually is 74,688. You just do those exactly like that. We're going to move on to the next one. So in this one, we're doing rods. Each rod is a centimeter square and of lengths of 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, and so on. We want to know which rods will measure a 9 rod. So we can have a 9 centimeter rod is this top one. And then 3 centimeters, we can put 3 of them together and that'll give you 9 centimeters. And then we could do the 1 centimeters with 9 of them and that'll give you 9 centimeters. All right, B is just the same thing, it's just with the 6 centimeters instead of 9. Now I want to know what the greatest common divisor of 9 and 6 are. So what we do is we'll write them out. So for 9, it's 1, 3, and 9. And for 6, it's 1, 2, 3, and 6. The only one they really have in common besides 1 is 3. So that is our greatest common divisor. All right, so on the next one, it wants you to show all the rods or trains which will measure an 18 train. So we got 18 centimeters at the very top, 2 9 centimeters, 3 6 centimeters, 6 3 centimeters, and I'm sorry. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 2 centimeters, and then we have 18 1 centimeters. And the other part is just listing the numbers. Okay, so let's go to our next problem. Find the least common multiple in prime power form, excuse me. Okay, so in order to do these, we need to find the least common multiple. We're going to divide by prime factors. So we're going to divide each number by the same prime factor, replace the term containing the prime factor by its quotient, continue until the last row contains only prime numbers and ones. So we'll work a couple of these. All right, so the first one we're going to do is the least common multiple of 40, 12, 44, and 363. The numbers didn't show up too good. Sorry, guys. All right, so the first prime number we're going to use is a 2. A 2 goes into 40 20 times. 2 goes into 12 6 times. 2 goes into 44 22 times. And 2 does not go into 363 evenly. So let's go for our next one. We'll do 2 again. 2 goes into 20 10 times. 2 goes into 6 3 times. 2 goes into 22 11 times. And again, it does not go into 363. So we'll just bring that number down. We'll do 2 again. 2 goes into 10 5 times. 2 does not go into 3, so we'll bring the 3 down. 2 does not go into 11, so we'll bring the 11 down, and same with 363. The next number we're going to use is a 3. 3 doesn't go into 5, so we just drop it down. 3 goes into 3 1 time, so we bring 1 down. 3 doesn't go into 11, so we bring 11 down. 3 goes in 363 121 times, so we write that here. The next one we'll do is 11. 11 doesn't go into 5, so we bring it down. 11 doesn't go into 1, we bring 1 down. 11 goes into 11 1 time, and 11 goes into 121 11 times. Now, as you can see right here on this row and at the very bottom row, we have nothing but prime numbers. So we're going to write them out over here. So we have 2 2s. Oh, that's 2 to the 3rd power times 3 times 5 times 11 squared. All right, let's see, we'll do one more. So the least common multiple of 250, 28, 44, and 110. So you write those out. It goes into 2, 125 to 14, 22 to 55. 2 again, 2 doesn't go into 125, so you bring it down. 2 goes into 14, 7, 2 goes into 22, 11, and doesn't go into 55, so you bring it down. Our next number will be 5. 5 goes into 125 25 times. 5 doesn't go into 7, so drop it down. Same with 11, drop it down. 5 goes into 55 11 times. Our next number will be 5 again. 5 goes into 25 5 times. It doesn't go into 7 or 11, so we'll just drop those down. And then you write it over here. All right, so we're going on to the next problem. This one didn't scan very good either, sorry. So in a machine, a gear with 48 teeth is engaged with a gear with 84 teeth. With teeth A and B on the small and large gears, how many more revolutions will the small gear have to make before A and B are again in the same position? So in order to solve this, it sounds a little difficult, but in order to solve it, you need to find all the multiples of both 48 and 84, then find the greatest common multiple, which you will divide by 84 by, and that will give you your answer. So I've worked it out down here. So the multiples of, not the multiples, factors of 48 is 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. The factors of 84 are listed here: 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. Now you look through and you want to find the greatest common multiple, greatest common factor. So they have 1, 2, 3, and 4, and 6. There's 12, and there's no numbers higher than 12, so 12 will be your greatest common factor. So then you'll divide 84 by 12, which gives you 7. So the answer is, it'll be 7 revolutions before point A and B are back the same. All right, now we're going to do our last problem, which is magic squares. Now this can be a little scary when you first look at the magic squares, but I'll break it down for you and hopefully it'll be a piece of cake afterwards. So in order to solve a magic square, you're going to need to find the magic sum. And how you find the magic sum is you add up all the integers. So right here is our integers we're using is -7, -6, -5, -4, -3, -2, -1, 0, and 1, which when you add those all together gives you a -27. Now to figure out what the magic sum is, our magic square has 3 rows. So you're going to go 3x equals -27. X is equal to -9. So the magic sum is -9, which that means every row, every column, and diagonally needs to equal -9. Now to figure this out, you're gonna plug x into the equations below. So we have x plus 3 in this top corner, x minus 1 over here, x goes in the middle, x plus 1 here, and x minus 3. Now to find what x is to solve these equations in the square is you're going to divide -9 by 3 because there's 3 rows. So -9 divided by 3 gives you a -3. So -3 plus 3 goes here, -3 minus 1 goes there, -3 is in the middle because that's what x is, -3 plus 2, and -3 minus 3. All right, so -3 plus 3 gives you a 0, -3 minus 1 gives you a -4, -3 again is in the middle, -3 plus 2 gives you a -2, and -3 minus 3 gives you a -6. Now, to solve for the other squares that aren't given numbers up here, you just guess and check, which we have 5 goes here, -5, a -7 here, -1 here, and +1 is one of the ones they gave us. So -7 and a -2 gives you a -9. A -5, a -3, and a -1 gives you a -9. -6, a -4, plus a 1 gives you a -9. So you got to check to make sure each row and column and even diagonally, which is 0 minus 6 minus 3 is a -9, equals the sum of the magic square, is the magic sum. which it is, all of them equal -9. All right, that's all I have for you guys on number theories and integers, and I hope